Hey everybody, this is Tim with Op-Ed Daily. So a lot of people don't know this, but there is a possibility that COVID-19, like once you get infected with it, you may never be able to get rid of it. I know that sounds alarmist and kind of crazy, but that's what is suggested in this study here that was posted on May 24th, 2020, that the news media just didn't care to talk about or anything like that. So what they found in this study is that functions that are found in other viruses like HIV, herpes, papillomavirus, pick a virus that remains in your body for life. They find that this SARS-CoV-2 shares that same function. And what it does is it evades the immune system by downregulating this MHC-I molecule. Now, I'll get into, the what and the why and putting it all into layman's terms for you. By the end of this video, you'll have a great understanding of what's going on, like the functions behind it and what happens. But just, suffice it to say that the possibility is here that you may not be able to get rid of it. And that means that forever you will have these reoccurring infections of coronavirus till the end of your day. Now, I'm not saying that it's 100% for certain going to happen, and I'm not saying that even if it does happen, that it will happen to everybody. That remains to be seen, but this is more of a, hey, just so you know, it's probably not a good idea to go and get COVID or risk getting COVID at this time until we figure out more what exists here. And keep in mind that this function did not exist with SARS-CoV-1, right? The SARS that we had under Obama, this function was not there. So this is a gained function in COVID-19 as opposed to any other coronavirus before. Now, I'm going to go ahead and in layman's terms explain the science behind this. And who am I to explain anything to anybody, right? I'm not a scientist. I'm not a doctor, researcher, geneticist, anything like that. But I did have cellular biology, microbiology, anatomy and physiology, and medical terminology in college. So I have a very good foundational understanding of the science behind a lot of what's going on and what is explained in this study. So I can take what I know and express it into ways that other people can better understand it. Because if you read this and you're not sure about what everything is, you may get confused or have to Google a lot. I do the research so you don't have to, right? But if you do want to read it, I'll leave the link to this below, and you'll click on this red download PDF, and it's a lot more than just this summary, but I'm just going to focus on the summary. So I'll read the title here. The orphate protein of SARS-CoV-2 mediates immune evasion through potently downregulating MHC-I. Now, MHC-I stands for Major Histocompatibility Complex Class 1. There's 3 different classes of that MHC, and this one is referring to Class 1. What that is kind of a flagpole, right? And different flags get flown under different circumstances. Now, I'm going to put this into kind of a silly story, but I think it'll help everybody understand the science and the why behind it. So imagine the cell is a bank, and police officers are your immune system, and a bank robber is the virus. And inside the bank, there's this little button that can be pressed. And on the outside of the door to the bank is a flagpole. And normally the flagpole is flying, let's just say the U.S. flag, right? So when everything is fine and there's nothing wrong, the U.S. flag is being flown on a flagpole just outside of the door. So when the police or the immune system drives by out in front of this bank, they look and they see, oh, the flag it's the U.S. flag. Everything's fine, right? Well, whenever the virus comes in, or the bank robbers, and they start to rob this bank, and the teller in the bank, or nucleus, or whatever you want to call it, pushes this button, what it does is it takes a picture of these bank robbers And now instead of outside of the door, and instead of it being a U.S. flag that's being flown, now it's a picture of these bank robbers. So this is the normal, this is the normal process for when a virus infects a cell. So now when the police roll by, they see this flag and they're like, oh, there's something going on inside. We need to go check it out. So they go in and eradicate this virus. Now, if I'm being true to the actual story here, in this case, the immune response would be from these cytotoxic T lymphocytes, right? And so those police driving by, they wouldn't come in and eradicate the bank. What they would do is they would come and basically blow it up and kill everybody inside of it, and then take little parts of the bank and ship it off somewhere else. But, we're not mean and cruel like that, so we're not going to do that to those people inside the bank. They didn't do anything wrong. And in the case of where this downregulation is occurring of this MHC molecule, what it does is the bank teller is pushing that button, but before the virus came in, or right after they came into the bank, before those bank robbers came into the bank, they took the flagpole down. So now there's no flagpole. So even if they're clicking the button, there's no flag is being changed. It's neither a U.S. flag, nor is it a picture of the bank robbers, right? So now the police come by, there's no flagpole. They're just like, wow, I guess maybe they're on break, right? And they just go on by. So that's what's happening here. It is removing the ability of a cell to tell the immune system, hey, I'm infected. Come and kill me, right? That's what its normal purpose is. So under normal circumstances, they have what are called these proteasomes that will break down proteins and various things inside the cell. And these get turned into peptides. If I'm remembering correctly, they get turned into these peptides, which are then sent up, however this functions, sent up on this MCH or this MHC molecule. So now these peptides that are normal breakdowns of what's inside the cell, they're being flown on this MHC molecule that's sticking up on the outside of the cell. Well, when a virus comes in, now there's different proteins being produced that are foreign to the cell. So when those things get broken down inside the cell, well, those new peptides, now they're being flown on this molecule sticking up on the outside. So then an immune cell comes by and it's like, that doesn't look right. That's not normal. And what that's called is an antigen. That thing that's sticking up with those different peptides on it, that's the antigen. And that produces an adaptive immune response, right? So these immune cells that are floating around, they're like, whoa, 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 whoa. And then in the case of these cytotoxic T lymphocytes, they'll come over there, attach themselves to this infected cell, and they have like this process button or whatever. They get it started, the process of autophagy, whatever you want to call it, where it self-destructs. It shrinks down and it starts packaging everything up into these little tight, neat little packages, and then eventually you've got all these broken up pieces of cell, and then other immune cells come and sweep up and eat and get rid of all of those little parts. So no more virus, no more cell, and some of that may get repurposed, but a lot of it will end up being filtered through your organs and then out, either one side or the other. So that's how that works. Of course, and that process is called apoptosis or apoptosis. So that's the function. That's how it's supposed to work. And in this case, it removes that antigen. There's no ability for the cell to stick out a flag and say, help, help. There's nothing like that. So this virus remains inside the cell undetected by the immune system. And even if the immune system is able to clear out all the other cells that have been infected and that weren't able to, by this open reading frame, be able to produce a protein that interacts and removes this MHC molecule, not all of them are going to be able to do that, right? Or at least not quickly enough, and the immune system will then catch them and get rid of them. But then there will always be a few of these cells that are infected, and then eventually you'll have another flare-up because it'll start replicating other viruses. This is how it works with many of these other things. So think about herpes, how you have, you'll get like a cold sore and it'll go away. And you'll get a cold sore and it'll go away. So that's the cold sore comes, the immune system comes in and takes care of it. And then it kind of lays dormant for a little bit. And then it comes and then it lays dormant. So that's probably what we'll end up seeing here. And the reason this came to mind, I'd posted this in a Facebook group that I run called Oklahomans Concerned About Coronavirus. I'd posted this months ago, but we started seeing reinfections starting to get talked about in the media, and I was thinking to myself, well, what if these are reactivations and not reinfections? Right? So then I was like, well, I should do a video about that. So that's what I'm here doing now. So it really is important to know this. And again, I'm not saying that it's 100% fact that you will always have coronavirus or COVID-19. I'm not saying that at all. I'm saying that the ability for it to evade the immune system does exist according to the study. But again, we're still learning a lot about it. And this could prove false. This could prove, that some of the methodologies they used to discover this were incorrect, or some of the tests weren't right. So that all of that stuff is possible. But for the sake of being cautious, it's probably better not to get it until we can figure it out. I certainly don't want to roll the dice on whether or not I'll always have it. Because can you imagine where every couple of months or every year, whatever, you end up with coronavirus, whether you go outside or not? That would suck, And we have seen cases of that where people didn't leave their houses and got, quote unquote, reinfected. So it seems like this is possible, and everybody should be aware just so that they can take that information and make an informed decision about what they want to do. But if you have information that either debunks or reinforces what I've talked about today, please leave that link in the comment section below. I'll see all the comments that you leave in there. So please do that, because I'm always looking for more information, and it'll get published in my Facebook group if it's good intel, if you will. If you disagree with anything that I've said here, or if I've made a mistake, it's been years since I've been in college, so forgive me if I've made a mistake. Please correct me in the comment section below. And if you liked this video and would like to hear more, please hit the subscribe button and the notification bell so that you can get notified whenever I drop another video. All right, guys, thanks for listening. This is Tim with Op Ed Daily. Peace out.